Okay, let's get started with topic 3.2. This is about life cycle analysis. I got some of this information from the World Business Council for Sustainable Development. The base of this presentation was from them, and I have tweaked in a few things with the IB information. So we're also going to talk about the life cycle. We're going to talk about life cycle analysis and also eco labels. Let's get started. This is, again, focus primarily on the new test for IB. Eco-design, what is it? It's defined by IB as having a consideration of the environmental impact of any product, service, or system during its life cycle. It should be instigated at the earliest stage of design and continue through to disposal. Designers should have a firm understanding of their responsibility to reduce the ecological impact on the planet. Eco-design concepts currently have a great influence in many aspects of design. Eco-design is not just designing for the environment, it's designing to be cost-effective. It's designing with materials and resources and even shipping and disposal in consideration. International mindedness aspect of this, the differing stages of economic development of different countries and regions and their past and future contributions to global emissions is an issue. When you look at what countries are doing around the world to try to reduce their carbon footprint, their emissions, there's a huge difference between, for example, what the United States is trying to do and what China is trying to do. They approach it from different ways. Some people in the United States say that China and India and other developing countries aren't working hard enough, so that creates a little bit of a friction between people from the different countries. When you look at theory of knowledge, nature does not create waste. There is no waste. Should areas of knowledge look at these natural processes beyond human endeavor? How can we look at nature and involve that in design to design things that are more ecologically friendly? Now, the product life cycle is basically a way for designers to consider the whole product cycle of a product. That is, how much energy is being used to mine the materials that are used in its manufacture, how much energy is being used to manufacture the products themselves, how many materials are being used in the production, in shipping, in usage, and then what's happening at end of life with disposal. Are these things being thrown into landfills? Are they being properly recycled? Are they leaching mercury and cadmium into our soil? What's going on with these things? A product life cycle analysis looks at that process. International mindedness, there's a big transition from a linear to a circular economy. That is, if you think of that video from William McDonald, there is no away. We used to throw things away. Well, where is away? The Pacific Ocean is not a giant toilet that doesn't flush. We gotta look at it from a different angle. We gotta realize that stuff stays around for a long time. So a plan needs to be put into place to dispose of and deal with the end-of-life materials. Theory of knowledge, design considers areas other than man in its thinking. Are other areas of knowledge confined to human influence and values? What else is out there? I mean, what are other ways of considering proper designs? Here's a few facts for you. Producing 1 ton of recycled steel saves the energy equivalent to 3.6 barrels of oil and 1 ton of iron ore compared to the production of new steel. Metals are almost universally recycled, and they've been almost universally recycled for years, not because of any great love of the environment by early industrialists, but rather it was a lot cheaper to take used up metal that wasn't being used for anything else, stuff in a junkyard and a scrapyard, melt it down and reuse it. It was much cheaper to do that than it was to dig it out of the ground and re-refine it. Producing paper using a chlorine-free product uses between 20 and 25% less water than conventional chlorine-based paper production. So it's not just a matter of the environment, it's also a matter of efficiency. Look at the stages of a life cycle. You can take a product and evaluate them from various stages. There's several main stages. First, you have the acquisition of raw materials. Then you have manufacturing and processing. Then you have distribution and transportation. Use and reuse, that is how people are using them in their homes or offices or whatever. Recycling and then disposal are kind of go hand to hand. In each of these stages, to do a proper analysis, you need to identify the inputs of material and energy received and the outputs of useful product and then waste. Another fun fact for it takes 1/4 pound or 3/4 pounds of chemical fertilizers and pesticides, three quarters of a pound to produce the amount of cotton required for a pair of jeans. That is a lot of material that's being dropped in our soil just to act as a fertilizer and a pesticide. That's not necessarily good for the environment. Not only that, is it gets expensive. That's why you want to get organic cotton. Now, a life cycle analysis helps avoid shifting the issues. It's easy to say, well, we'll make something using a less toxic material. We'll make this widget using a less toxic glue. Okay, well, you're using a less toxic glue. Well, when the customer gets that, if it falls apart and they glue it back together using that same old toxic glue, then that's not really a help. You're just shifting the burden from manufacturing to the use and reuse. So the life cycle analysis looks at the whole thing and tries to prevent shifting problems from one part to another part. And designers need to be conscious of this whole process and what's shifted and where it's being shifted. Now, why does this matter? Well, because if you think about it, something can be manufactured in a green factory, but if that green factory is 1,000 miles away from the market, well, you still got to pay the cost, and you still got to waste the energy shipping the product from your green factory to the market. So you really got to consider all points. The transportation is a big aspect of this. So you got to locally source things, save money on transportation, and save energy on transportation as well. With transportation, you also have the impact on groundwater, because when you have vehicles traveling, be they planes, boats, trains, automobiles, trucks, whatever, they are creating some sort of exhaust that comes out of the tailpipe, unless it's an electric vehicle or something like that. But they are creating some sort of waste, and that waste goes into the atmosphere, and that atmosphere can leach into water sources. And with groundwater, you have a few terms you need to learn. Potable means water that is safe to drink. Point source pollution. This is where you have contamination directly into a body of water. This is like dumping or overland runoff from farms. This is point source pollution. Non-point source pollution is pollutants that are delivered indirectly through transport or environmental change. This is like leaching from storage tanks, acid rain, sulfur in the precipitation, from the gases that come out of these vehicles and then get leached into the air and then get carried into the groundwater. That is non-point source pollution. Groundwater can be contaminated through overland runoff, through spills, through acid rain, through leaking storage tanks, overland runoff from non-permeable surfaces like roads. When you got cars sitting idling on a road and they are pumping their exhaust out of the tailpipe, that's going onto the ground. So roadways are usually covered in soot and all sorts of chemicals from tailpipes. Well, when water runs on that, you have water that rains and it flows down a roadway. It's carrying some of that with it. That works its way into rivers and streams. So you get runoff that way, and that runoff is not necessarily the cleanest. This image was taken from the U.S. National Geological Survey. There's different types of products that have different impacts. If you look at the 4 categories: materials, production, use, and end of life. If you have like a single-use package, for example, it takes a lot of use or a lot of materials, very little cost and very little use impact on the production or on the use, because pretty much you just open it up and that's it. End of life, I would argue, should be a little bit higher, because there's a lot of garbage from this packaging that's just one-time deals. Let's look at a manufacturing intensive product like a laptop computer or paper products. Here, it doesn't take a lot of materials to make a laptop, but it does take a lot of energy and a lot of specialized stuff for production. So you have quite an intensive impact, environmental load during the production. Not so much on use, but end of life should be, again, bigger, because disposal of electronics is a huge issue these days. Then you have type C, which would be long-lived energy and resource-consuming products. This would be an example of like a car, something that you can keep for 10, 15, 20 or more years. It requires a relatively small amount of materials and relatively low impact on production, but use, you're constantly putting gas into it, you're constantly maintaining it, you're constantly adding to it, so there's quite a bit of an environmental load in the use stage, and then end of life, again, disposal is always an issue. Then you look at diapers, disposable diapers. They don't take much in the way of materials, production, impact, or use, but they accumulate. You can get thousands of diapers per kid per year. So you multiply this times all the kids in the world, and you see how landfills are filling up with these disposable diapers. When you look at a life cycle analysis, when you initially look at a product before considering the whole analysis, let's take an example of a refrigerator. You think of just the price of the refrigerator. Okay, refrigerator A is cheaper than refrigerator B. But when you look at it a little bit deeper, you see when you consider the cost of use and the cost of disposal and post-disposal, you'll see that refrigerator B in this case is less expensive overall. That goes for not just cost but also environmental impact. With a life cycle approach, companies will employ tools to not only reduce impacts across the life cycle, but also capitalize on these business opportunities that appear. And there's lots of ways to map the life cycle changes. And remember what William McDonald said about just using organic or just using natural materials isn't the way. If we all wear Birkenstocks and organic cotton, then the world will run out of cork and fresh water. There is a place for synthetic materials, and it's not always a bad thing to use plastics. You just have to know when to use them and how to use them and how to dispose of them properly. Now, the life cycle assessment is a tool to systematically measure the environmental impacts associated with each stage of a product's life cycle. Take a look at this diagram for the life cycle assessment of a t-shirt. You start with the raw materials. You could get those raw materials from recycling, or you can harvest them on your own. That uses fertilizer, energy, and water. Processing, that'll use energy, cleaners, and dyes. Manufacturing, then you have more energy and waste that's created from manufacturing. When you package, then you're going to use paper and plastic, and you're going to generate quite a bit of waste. Then you have to transport it to market. That uses energy. And then people are going to be cleaning their t-shirts, so that's going to use detergents, bleach, and water. Then from there, you can either reuse it and continue using it over and over again, you can dispose of it, or you can recycle it. Now, the full assessment, there are two specific attributes that make these life cycle assessments distinct and useful as analytical tools. First, they consider the whole system. They look at the whole life cycle of something, and they present trade-offs between different environmental issues. The other big thing is life cycle assessments are quantitative. That means you can do an assessment of one product and compare it to another product, and you have an apples-to-apples comparison. It's not something where you cannot easily draw correlations between two different products. Now, why take this approach? Well, it uses the systems perspective, and if you look at the systems model, that link will take you to Wikipedia explaining exactly what that is. It's critical for a lot of businesses, and it integrates not only cost and expenses, but also the environment into core business issues. Remember, it's not doesn't make just environmental sense, but also business sense to improve efficiency and innovation. You get a better return on your investments. You engage your stakeholders. People are interested in doing this sort of stuff. Your customers want to try to help the environment when it comes down to it. People aren't going to just want to throw everything away. They understand there is some impact here, and they want to help out. So this is a great way to get them involved. Environment doesn't create a kind of a way for businesses just to spend money, but a business opportunity. This makes companies kind of look beyond just the gate of the company. What happens when this product leaves the factory? Look at trade-offs and opportunities. Are there opportunities where the company can be greener or make more money? And then expand the analysis of products, projects, policies, and programs. What's the function? What are the boundaries? What are the impacts? What are the opportunities? Look at all of these things. Life cycle assessment does all of this. We're running out of time here, so let's. I'm going to switch to the next presentation. So after you're done with this presentation, go on to the next one.